Moving into question number 7. So 7.1 part A tells us using a formula from page 2 show that tan 2 theta is given by the following equation. So 1A, tan 2 theta, we know tan theta plus tan theta can be written as 1 minus tan theta into tan theta. So that gives us 2 tan theta and 1 minus tan square theta. And that's done for part A. For part B, it tells us given that tan 2 theta is equals to 1, show that tan theta is equals to A plus minus root over B, where A and B are integers whose values need to be found. So it is given that tan 2 theta is equals to 1, alpha is equals to 1. We can write it as 2 tan alpha divided by 1 minus tan square alpha equals to 1. And then we can simplify it as 2 tan alpha equals to 1 minus tan square alpha. And that gives us tan square alpha plus 2 tan alpha minus 1 equals to 0. So we're ended up with a quadratic equation. If we solve it, we will end up with tan alpha is equals to minus 1 plus minus root over 2. It's the exact way they wanted us to answer. Coming on to part 2A. It tells us using formula from page 2 show that cos x minus 30 is equal to sin x plus 30 can be written as tan x equals to 1. So cos x minus 30 equals to sin x plus 30. We can write them as cos x cos 30 plus sin x sin 30. And then for this one, we can write it as sin x cos 30 plus cos x sin 30. So we know cos 30 can be written as root over 3 by 2 minus half cos x. This is for this whole part actually, cos x cos 30 plus sin x sin 30. And then we can write the next part as root over 3 by 2 minus half sin x. So this is the remaining part of here. So if we just simplify it, sin x by cos x, root over 3 by 2 minus half, and then obviously root over 3 by 2 minus half. So that gives us tan x is equals to 1. Coming on to part B. Hence or otherwise solve cos 2y minus 30 is equals to sin 2y plus 30. So if we compare this part with this part, they're both the same. So we can simply write tan 2y is equals to 1. We knew tan y was equals to minus 1 plus minus root over 2. from the first part of this question. So y should be equals to minus 67.5 and 22.5 degrees. Carry out simple trigonometric calculations, then you will have this answer. That's it. We're done with question number 7.